All right, I just had a piece of cheese. I'm ready to go again. So now we are going to be talking about lesson 10-6. Using the quadratic formula. And honestly, I know this is what everybody works towards with all of this that we are doing with our quadratic equations. So using the formula. Okay, so this is it, the time where we actually use the quadratic formula. So first, let's talk about what is the quadratic formula. Quite simply, of course, let's start with if ax squared plus bx plus c equals 0, and a does not equal 0. Always very important that a can't equal 0, because then your x is gone and then you're really looking at a linear equation. Then x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Over 2a. And there it is. Woohoo! Even the llama's excited. Yeah, we're dancing in the streets. We finally have the quadratic equation. Yeah, quadratic formula. Finally have it. Woo! Yeah, okay, it's not that exciting. So, what I want you to see are the parts of it that I think are really interesting. First off, this part of it. This negative b over 2a. Negative b over 2a. Where did we see that before? Oh, I don't know. Maybe that's the axis of symmetry. So we've been working with negative b over 2a for a while. And then, what? What is this? Oh my gosh. No, it's the discriminant. You're joking. No, I'm not joking. B squared minus 4ac. There's the discriminant. Okay? So we have already used both parts of this, and now we're looking at it together. So you know, you can actually, you're using two parts of it. Now we're just going to use it together. I like to create it. I like to put it together, which is what we did by learning about the axis of symmetry first, finding the x, and the discriminant first, and now putting everything together. I think that once you can see it, the only parts that we were missing were plus and minus, and then the square root symbol. So using the quadratic formula is really quite simple. Let's go ahead and just work out a problem. Let's start with x squared minus 2x minus 8 equals 0. Okay, so what we are going to do is we're going to take negative b, which is a negative 2. So a negative 2. I just like to start properly, and we'll come back and fix that later, that's for sure. B squared, negative 2 squared, minus 4 times 1 times negative 8. Okay, and this is all over 2a. Now, a couple of things to look at with this. Once we calculate this discriminant, we know exactly how to proceed. So, so we're going to go ahead, we'll rewrite the whole thing properly. So this is 2 plus or minus, oops, that really came out badly, the square root of, and this is 2a, which is 2 times 1, so we've got a denominator of 2. So 2 plus or minus, now this is going to be 4. We've got negative 4 times 1, which is negative 4, times negative 8, which is a positive 32. By getting this, 4 plus 32, I know automatically I'm going to have two solutions to this. So rewriting again, we've got 2 plus or minus the square root of 36 over 2, which is equal to 2 plus 6 over 2, and 2 minus 6 over 2. This gives me 8 over 2, which is equal to 4, and this gives me negative 4 over 2, which is equal to negative 2. So for this problem, my x is equal to 4 and negative 2. Okay? Now, it's beautiful when it works out like that. And we're going to do one more problem where it works out just beautifully like that, and then we're going to get into the uglier problems. Now, the one thing that I do want to point out with that last problem before we get into some ugly stuff. So we had x squared minus 2x minus 8 equals 0. Now, I can tell you right off the bat that I could have factored this pretty quickly also with an x, plus 2, x minus 4 equals 0, x plus 2 equals 0, x minus 4 equals 0, x equals negative 2, x equals 4. So I would have still come out with my 4 and negative 2 answers by factoring. So part of what we're going to have to look at as we go through the quadratic formula is when exactly are we going to use it? Because sometimes you don't need to. Let's look at our next problem, which is x squared minus 4x equals 117. Okay, and we're going to, of course, subtract 117 from both sides so that we end up with x squared minus 4x minus 117 equals 0. So we've got negative b, which is negative 4, plus or minus the square root of b squared, negative 4 squared minus 4 times 1 times negative 117. I think you can already tell that with all of the multiplication of negatives that we're going to have here that, yeah, we'll have two solutions. And all of this goes over 2 times 1. So this is going to equal 4 plus or minus the square root of 16. And this is, of course, I'm going to come over here and do some side math. 117 times 4, 8, 2, 4, 6, and 4, 468, and it's positive because negative times a negative. 468 plus 16. I do love side math. 6, 7, 8. Just keep it neat. Still want to have that over 2. So 4 plus or minus, I don't even know what that is. Plus, I don't even know. Luckily, you can't see it. You can see it now. Okay, there he comes again, ready to watch because he doesn't know what I'm doing. This is a negative. I don't even know. I have no words. And this is the square root of 484, which, 25, 44, is that 24? No, that's 16. 22, is that 22 squared? Okay, so obviously I'm going to have to do this for, yeah, it's 22 squared. So, well over 2, which equals 4 plus or minus 22 over 2. So what I have here is 4. I always am running out of room. Why am I doing that? 4 plus 22, and I always tell kids, don't like go down to the bottom, and here I am going down to the bottom. 4 minus 22, so this is 26 over 2 equals 13, and this is negative 18 over 2, which is equal to negative 9. So for this problem, where it is, I don't even know where the starting problem is, all the way up here. This is x, oh, and now you can't see that because now I'm going too high up, equals 13 and negative 9. Okay, so once again, what does that mean? That means that my parabola is going to cross the x-axis at those two exact points. So going back, and now look, you've got 4 over 2 here. I can tell you that your axis of symmetry is at 2. Okay, so if you put 2 into this, you can find where your vertex point is. You know that it's a parabola opening upwards. so that your vertex is going to be a minimum. There are so many things that you know already before you even start to graph something. Okay, so that's a great looking problem. Now let's look at something that might turn out a little uglier, okay, just so that we are aware that this happens. Let's look at negative 3x squared plus 5x minus 2 equals 0. Okay, so negative b plus or minus the square root of b squared minus 4ac over 2a. Now, I want you to understand that one of the reasons why I keep writing it is that I know that the more you write something, the more it becomes part of your memory. So now I will go ahead and put in my b, which is negative 5 plus or minus. I've got the square root of b squared, which is 5 squared minus 4 times a, which is negative 3, times c, which is negative 2. Got 3 negatives there. Know what's going to happen. So, so let's see what, and then all over 2 times the negative 3 times negative 3. All right, so negative 5 plus or minus, and this is going to be 25 minus 4 times the negative 3 is negative 12 times 2 is going to be a positive 24, so minus 24. Look at that, it just made it. And all over negative 6. So this is going to equal negative 5 plus or minus 1 over negative 6. When I split it up, it's negative 5 plus 1 over negative 6, and negative 5, well, we'll split it up this way, negative 5 minus 1 over negative 6, and so this one is easy, negative 6 over negative 6 equals 1, and over here, oh, look at me jumping back and forth without even looking, at least you can still see, this equals negative 4 over negative 6, which is equal to 2/3. Now, some people are going to say, okay, that's 0.67 or 6 repeating. I don't like to get into repeats. I can find 2/3 just fine on a coordinate plane. It's 2/3 of what my, of what my boxes are. So I have no fear of fractions. So I'm going to have 2 answers, and I'm leaving it as 2/3 and 1. Okay? Why mess with repeating decimals? So understand that sometimes your answer can be fractional or it can be a decimal. So so that's pretty much it. I just want to spend just a quick moment talking about when we're going to use each of the methods that we have learned. So graphing. If graphing is going to be the first method you use, you really need to use all of the tools in your arsenal, and it just isn't really the best way to just go at a problem. And I think that you would all agree if you've been graphing some of these without any of the other information. Early on, it took us way longer than it takes now to graph them. If you have a graphing calculator, though, and if you are allowed to use it, go ahead and graph. Makes a lot of sense if you've got a graphing calculator. Okay, so if you're going to use square roots, we did this at one point. Square roots, if you have no b, actually, it says no x term, no b value, if you are just looking at an x squared, an ax squared plus c, if you are looking at this sort of thing, then go ahead and use square roots. Factoring, if you can easily see it, if you can easily see the factoring, and you don't have to work too hard for it. There is another method that we haven't really talked about, which is completing the square. For myself, I would rather just go ahead and use the quadratic formula. The quadratic formula for anything that just is not easily factored. Okay, so if the factoring is difficult or impossible, and sometimes that happens, if the factoring is difficult or impossible, use the quadratic formula. Okay, all of this is just to make the graphing of that parabola a little bit easier. Okay, so just as a quick review over all that we have learned and talked about, when you first look at an equation, let's say we've got 7x squared minus 2x minus 8 equals 0. If we look at the negative b over 2a, oops, bringing the guy in, because obviously I'm already messing up. Okay, negative b, so that's negative 2, which is 2 over 14. So I have 1 over 7 as my axis of symmetry. I also know it is the x value of my the minimum, because on my vertex. So the x value of my vertex. Okay, so if I know that if I put the 1/7 in, I would actually be able to get the y value, and I would know where my exact vertex point was. I know that if I take b squared minus 4ac, I know that b squared is going to be 4 minus 4 times 7 times negative 8, which is equal to 4 minus, so 4 times 7, 28 times 8, 8 times 8 is 64, 6, 8 times 2 is 16, and that's 22. So 4 negative negative plus 224 equals 226. So that means that I have two solutions. I also have done a good portion of my work for the for my quadratic formula. So I already know all of these things. I know that my parabola opens upward. I know, because this is 7, that my parabola is going to be pretty narrow. My axis of symmetry is at 1/7. I have two solutions. That means that I know, since my axis of symmetry is at 1/7, that if I put in values such as 0, maybe not 0, maybe 1, maybe 2, maybe 3, I'm going to get an idea of where everything is. So use your knowledge, use everything that you have in your mental arsenal to make this just easier. And then someday when you get into high school and you're using calculators, you will just curse the ground that I walk on, because I wouldn't let you use a graphing calculator to do it. And man, I gotta tell you, it's so easy with a graphing calculator. So, okay, so this ends the quadratic. Woo! It's party time again. Okay, so let the dancing and the celebration begin, because we're going to be having a test soon. Yay! Okay, thank you.